You're using it right now, but you've probably never given it a second thought. It's the engine that powers pretty much the entire modern internet, and it's called IPv6. So let's dive in and take a look at this massive, essential upgrade that's been quietly reshaping our digital world.
Here's the easiest way to think about it. For any data to get from a server somewhere out there to your screen, it needs an address, just like a package needs your home address. The original internet, IPv4, was kind of like the first blueprint for this digital city.
And, well, that's exactly what happened. The internet grew bigger and faster than anyone ever dreamed possible. And we started to run out of those crucial IPv4 addresses. Our digital city was facing a massive worldwide housing crisis.
And look, this isn't ancient history. This all happened pretty recently. Starting in 2011, the big regional groups that hand out IP addresses just started running out. That pool of 4.3 billion addresses that seemed endless? Poof, it was gone. The well had officially run dry.
So you might be asking, how is my internet even working then? Well, for years now, we've been relying on this clever but clunky patch called NAT. It lets all the devices in your house, your phone, your laptop, your TV, all share one single public address. But it's just a workaround, and it causes all sorts of weird problems for things like online gaming or video calls, because it breaks that clean, direct connection between devices. So the real fix wasn't another patch, it was a whole new blueprint. And that's where IPv6 comes in. It was designed from the very beginning to make sure we would never, ever have this problem again.
Just look at that number. Seriously, that's 340 undecillion. That is the number of unique addresses IPv6 gives us. It's a number so ridiculously huge that it's almost impossible to even wrap your head around without some context.
So let's try to put it in perspective. You could give 45 quadrillion addresses to every single grain of sand on the entire planet. This isn't just a bigger city, it's an entire universe of addresses. The bottom line here is simple. The problem of running out of addresses is solved. For good.
Okay, I get it. The first time you see an IPv6 address, it looks like an alien wrote it. It's long, it's got letters, it's got all these colons, it just looks complicated. But trust me, there are just two really simple rules that make it all make sense.
So here it is in all its glory. The full, scary version. It's a total mouthful, and yeah, trying to type that would be a nightmare. But the good news is, nobody ever really does that. It all comes down to two magic tricks. First, you can just drop any zeros at the front of a block. Simple enough. Second, and this is the big one, if you have a whole string of blocks that are just zeros, you can squish that entire section down into a double colon. You can only do that once per address, but it makes a huge difference.
And boom, look at that. All those clunky zero blocks just vanish. That long, intimidating string on the left turns into the much nicer, cleaner address on the right. That double colon just means, hey, fill in the missing zeros here. See? Not so scary after all. But here's the really cool part. IPv6 isn't just a bigger gas tank for the internet. It's a completely redesigned engine. It's smarter, it's faster, and it's way more efficient. Just take a look at the packet headers side by side. The IPv4 header on the left is, well, it's a bit cluttered. The new IPv6 header on the right is so much cleaner and simpler. It's like trading a confusing old dashboard for a sleek modern one. And that simplicity makes a huge difference for speed. So what did they chop out? Two big things. First is the header checksum. With IPv4, every single router had to stop and do math on every packet that passed through. A massive bottleneck. IPv6 gets rid of it. Second is fragmentation. Routers don't have to chop up big packets anymore. That job gets pushed to the devices at the edge, which lets the big core routers do one thing and one thing only: forward packets at lightning speed.
Now, this might be one of the absolute best features of IPv6. It's called Stateless Address Auto-Configuration, or SLAAC for short, and you can basically think of it as true plug-and-play for the entire internet.
So check this out. When your device joins a new network, it just sends out a little message, kind of like shouting into a room. Hey, is there a router here that can get me to the internet? The router on the network hears that and replies, yep, I'm right here. Here's the network's address. Your device takes that information, generates its own unique ending for the address, and that's it. It has a globally unique IP address and is on the internet. No central server, no waiting for permission, it just works.
IPv6 also completely gets rid of the idea of a broadcast. In the old IPv4 world, a broadcast is like pulling a fire alarm. It's loud, and every single device on the network has to stop what it's doing and pay attention. Super inefficient. IPv6 uses multicast, which is much more like sending a targeted email. Only the devices that are actually part of that group even listen to the message.
So we have way more addresses and a much smarter network. That's great. But what does it actually mean for you? Why should you care? Well, the payoff is a better internet experience. All those weird gaming and video call problems caused by NAT, they start to go away. It makes direct connections between devices easy again. It provides the trillions and trillions of addresses we need for things like the Internet of Things and 5G. But maybe most importantly, it brings back the original, beautiful vision of the Internet, a network where any device can talk directly to any other device.
Now, an upgrade this massive doesn't happen with the flip of a switch. It's been a slow-motion transition, happening for years in the background, all designed to be as smooth as possible.
The main strategy is called dual stack. It's a really simple concept. Your phone, your computer, and the routers just run both IPv4 and IPv6 at the same time. They speak both languages. If a website is available over IPv6, your device will use it. If not, it just falls back to the old IPv4. In fact, you've probably been using it this way for years without even knowing.
And this really gets to the heart of it. IPv6 isn't just some technical upgrade. It's a return to a core principle. It's about getting back to a truly open global network, where every single device is a first-class citizen, not stuck behind layers of workarounds and complexity.
So that leaves us with a pretty fascinating question. For the last 2 decades, we've built amazing things on an internet that was fundamentally constrained, patched together. So what are we going to create in the next 20 years with an internet that has, for all intents and purposes, no limits at all?